Hello everyone, I am Aakash of class 12. Here I am going to explain about measurement. In that I am going to discuss about density. Let us start from density. Here the density formula is density is equal to mass by volume. Density can be converted into several systems: FPS, DF, SI unit, MKS, CGS. Now we can see about the full form of following systems: FPS, foot, pound, second, system; DF, dimensional formula; SI unit, international system of unit; MKS, meter, kilogram, second, system; CGS, centimeter, gram, second, system. Now we can learn about density. The density of a substance is defined as its mass per unit volume. The symbol most often used for density is P, although the Latin letter D can also be used. Therefore, density is equal to mass by volume, that is kg per meter cube. Now we can move to common SI prefix of density. Mega density 1 into 10 to the power of 6 D. Kilo density 1 into 10 to the power of 3 density. Hecto density 1 into 10 to the power of 2 D. Deca density 1 into 10 to the power of 1 D. Giga density 1 into 10 to the power of 9 D. Now we can go to base unit. 1. Deci density 1 into 10 to the power of minus 1 D. Second, centi density 1 into 10 to the power of minus 2 D. Third, milli density 1 into 10 to the power of minus 3 D. 4. Micro density 1 into 10 to the power of minus 6 D. 5. Nano density 1 into 10 to the power of minus 9 D. 6. Pico density 1 into 10 to the power of minus 12 D. Now let us learn about density in several systems. Density in FPS. Here LB by cubic feet is equal to LB per cubic feet, or LB per FT power minus 1. LB is equal to pound, FT cube is equal to cubic feet. Therefore, LB by FT cube. Note, 1 pound is equal to 0.454 kg or 454 gram. Density in DF, I mean dimensional formula. Density is equal to mass by volume. Here mass is considered as M, volume is considered as L cube. Dimensional formula is ml power minus 3. Now we can move to SI unit. D is equal to M by V. That implies kg by m cube, or kg per centimeter cube, or kg centimeter power minus 3. Now we can move to MKS. D is equal to M by V, which implies kg by m cube. Kg is equal kg per centimeter cube, kg centimeter power minus 3. CGS. D is equal to M by V, which implies gram by centimeter cube, or gram per centimeter cube, or gram centimeter power minus 3. Now we can let us discuss about derived formulas based on density with their SI units. Number 1, derived formula mass density, SI unit kg per meter cube. Number 2, current density ampere per meter square. Number 3, magnetic flux density Weber per meter square. Number 4, heat flux density work by meter square. Number 5, energy density joule per meter cube. Number 6, electric charge density coulomb per meter cube. Number 7, electric flux density coulomb per meter square. Now let us discuss density formulas based on MPM. MPM means model problem mapping. This can be done based on density. Now first we can consider mass density. Here mass density formula is D is equal to M by V, or gram per centimeter cube. Here they have given as example that mass as given as 60 gram, volume of liquid is 35 centimeter cube. Now we can apply these values in formula and we can get the answer. Now we can move to current density. Current density they have given that I and area. I is 5 meter ampere, area is 15 millimeter square. We want to find current density. The formula is J is equal to I by A. Next we can move to magnetic flux density. In this they have given number of turns as 50 and resistance as 0.5 meter and current as 5A. We have to find magnetic flux density. We can use formula B is equal to mu naught Ni by 2R. Then we can move to heat flux density. In that they have given area is equal to 0.03 meter square and charge is equal to 120 into 0.12, that gives us 14.4 watt. We have to find heat flux density, so we can use formula that as Q is equal to capital Q by A. Then we can move to energy density. In this we have to find energy density by using U is equal to half E naught by E square. So that's so that we can get this. By using this we can get the answer. Next we can move to electric charge density. Here we can use formula as P is equal to Q by V. We have more formulas in electric charge density. Let us discuss in upcoming slides. Electric flux density. In this we want to find the electric flux density by the given values. They have given the area and magnitude of electric field and angle. Always we want to consider angle is equal to 0 degree. By using the formula phi is equal to Ea cos theta, we can get the electric flux density. Here I have drawn the metal density chart based on some common metals which we are using in day-to-day life. Here I have used about 10 metals. I have converted each metal's density in kilogram per meter cube, gram per centimeter cube and lb per cubic feet. Now let us move to density in state of matter. Here I have drawn different types of states with their density. In gaseous state the density is very lower, but in liquid it is in medium state and in solid it is in higher state. Now let us discuss about some example sums based on the derived formulas. Now we can move to sums based on density. Question: mass of a metal is 120 gram and volume of a metal is 60 centimeter gram. What is the density of metal? They have given the volume of metal and mass of metal. We want to find the density. The formula can be used is D is equal to mass by V. By using this formula we can find the density of metal. Now we can get the sum by applying these formulas. Example: density in gram per centimeter cube. They have given the mass of a metal as 120 gram and volume of metal as 60 centimeter. By using this we can get the answer as 2.00 gram per centimeter cube. By using this method we can find answer for density in kilogram per meter cube and density in lb per cubic feet. Now we can move to example sums based on current density. Question: determine the current density of 100 ampere of current is flows through the battery in an area of 10 meter square. Given current I is equal to 100 A, area is equal to 10 meter square. We have to find current density. Formula J is equal to I by A. By applying this formula we can get the answer. Here J is considered as current density in ampere per meter square. A is considered as the cross section. I is considered as current flowing through the conductor in amperes. Now let us do another problem based on the same formula. A 15 mm copper wire has current of 5 mA of current which flowing through it. Find out the current density. It is also the same method. By using the same formula we can get the current density easily. Example sum based on magnetic flux. Question: calculate magnetic flux density of magnetic field at the center of a circular coil of 15 turns having radius of 0.5 meter and carrying a current. In this they have given a number of turns is equal to 50 turns, resistance is equal to 0.5 meter, current is equal to 5 amps. We want to find magnetic flux density by using the formula B is equal to mu naught Ni by 2R. SI unit is Weber per meter square. By applying this formula we can get the answer. Answer is 3.14 into 10 to the power of minus 3 Weber per meter square. Now let us discuss about example sum based on heat flux density. Question: a 15 into 1020 cm circuit board holds 120 closely spaced logical chips, each dissipating 0.112 watt. If the heat transfers from the black surface of the board is negligible, determine using heat flux formula. Here we have two subdivisions. In 10 option A, in 10 hours, how much amount of heat this board dissipates? B, the heat flux on the surface of the board in W per meter square. Solution. They have given the area of board and heat dissipated by each chip. We have and they given total count of chip on the circuit board. Heat dissipated by all chips on the circuit board. So we want to multiply 0.12 into 120. We can get the answer as 14.4 watt. Here we want to find two things. One is heat dissipates in 10 hours and heat flux density. We can use formula Q is equal to capital Q by A. Subdivision A, heat dissipated in 10 hours. 14.4 into 3600 into 10. We can get the answer at 518.4 kilojoule. Subdivision B, heat flux density in the board. Q is equal to 14.4 by 0.03. We can get the answer as 480 W per meter square. Let us move to example sum based on energy density. Question. In a certain region of space, the magnetic field has a value of 3 into 10 to the power of minus 2t and the electric field has a value of 9 into 10 to the power of Vm per meter per second. Determine the combined energy density of the electric and magnetic field both. They have given B is equal to 3 into 10 to the power of minus 2t and E is equal to 9 into 10 to the power of 7 Vm meter per second. E naught is equal to 8.85 into 10 to the power of minus 12 coulomb per meter square. U is equal to 4 into pi into 10 to the power of minus 7 Newton per ampere square. We have to find total energy density. They have given B is equal to magnetic field, U is equal to energy density, UE is equal to electrical energy density, UB is equal to magnetic energy density, E naught is equal to permittivity, E is equal to electric field. Formulas. We have three formulas, for one for energy, electrical energy, another for magnetic energy and for energy density. Electrical energy, UE is equal to half E naught E square. UB is equal to half 2 U naught B square. This is for magnetic energy density. Then another formula is for energy density. U is equal to UE plus UB. By applying first formula, that is electrical energy, we can get the electrical energy density, and by applying second formula we can get the magnetic energy density. By adding these electrical energy density and magnetic energy density, we can get the total energy density, that is U is equal to UE plus UB. Example sum based on electric charge density. Note, formula for charge density. There are three formulas based on linear surface and volume. Linear charge density. Lambda is equal to Q by L, sigma is equal to Q by A, P is equal to Q by V. Here they have given lambda as linear charge density, sigma as surface charge density, P volume charge density, Q electric charge, A area, L length, V volume. SI unit is coulomb per meter cube. By using this, we can do one question. Question. Determine the charge density of an electric field if a change of 6 coulomb per meter is present in a cube of volume 3 meter cube. They have given Q is equal to 6 coulomb per meter, volume is 3 meter cube. By applying we have to find volume charge density. By applying the formula P is equal to Q by V, we can get 6 by 3, that is P is equal to 2 coulomb per meter cube. At last we can move to example sums based on electric flux density. Question. A uniform electric field E is equal to 8000 Newton per coulomb passing through a flat square area is equal to 10 meters square. Determine the electric flux density. They have given the magnitude of electric field and area. We want to find the electric flux density. We can use formula phi is equal to EA cos theta. Here cos theta is 0 degree. Always we have to keep angle as 0 degree. By applying this formula, we can get the answer as 8 into 10 to the power of Newton per meter square per coulomb. So the electric flux density is 8 into 10 to the power of Nm square by coulomb. References based on density. Refer Physics CBSE textbook class 11 and refer NCERT class 11 12 sums, that is www.ncert.nic.in, and you can use Physics State Board Tamil Nadu textbook class 11, and also we can use saitechinfo.net, and we can use metricconversion.org. Thank you for watching. Kindly see the website saitechinfo.com.